Hello everyone. In this lesson, we're going to learn more about how to work with text data in Python. Text data cleaning and pre-processing can be one of the more time-intensive tasks involved with preparing a data set for analysis because text data can have a lot of irregularities in it that may need to be corrected before it is useful for analysis. So in this lesson, we're going to go over a variety of different functions that you can use for working with text data, which in Python are known as strings. We're going to start off by loading in a data set on Kaggle. This is actually going to be a data set of Reddit user comments related to the NBA basketball team, the Minnesota Timberwolves, because that is the team from the state where I am from. And this provides an example of how messy some text data might be. So we just extracted 8 comments from this subreddit, and we can see that there's a lot of different types of text in here. This one just looks kind of like a normal comment. This one looks like it is some kind of embedded web link. And this one here is some kind of emoji where there's not any actual normal letters in it. So to use this sort of data for an analysis, there's a good chance you're going to want to do some text pre-processing steps to figure out what elements of these strings are even worth looking at. So we'll go over a variety of functions available in the Pandas package that you can use for doing operations on text data. First, there is a pandas function .lower that will change all text to lowercase. So for instance, if we look at the first comment in our data set, so that's comments 0, and then we run .lower on it, it will convert that entire comment to all lowercase. And similarly, we could use .upper to make things uppercase. So this is going to take all of the comments.stir for string.upper, and we'll just look at the first 8, but this is converting all of the comments to all uppercase. You can also use .stir.len to check the length of all the different strings. So if we run comments.stir.len, we'll check the first 8 of those with .head8. We're getting the length of the first 8 comments. So Pandas also has string splitting and stripping functions, so we'll show how to use some of those. The split function takes a string and then splits it up into a bunch of substrings and puts them into a list based on some separator. So in this case, we're going to run comments.stir.split, and then the argument in here is what we want to split on. In this case, we're going to just split on blank spaces. This is a way you can create a list of all of the words in a string, provided those words are separated by spaces. And the .strip method will take off a given character off of the front or end of a string. So here we can, for instance, run comments.stir.strip and pass in square brackets, and that will strip off any opening or closing brackets at the beginning and ends of a string. So we can see this comment here, comment number 1, used to have an opening brace here, because here's the closing one, and that has been successfully stripped off. And if you pass in a blank space here, like this, you can use strip to strip off white space. So that is probably the most common reason to use strip, but you can pass in different characters like this to strip those off as well. Now, if you have a pandas series of several different strings, you can combine them all into one long string using .cat for concatenate. So I'll show how to do that here. We can take our comments and say .stir.cat, and that will take them all and paste them essentially into one gigantic long string. So we'll run that, and we're only going to look at the first 500 characters here, because if we actually printed that whole thing to the screen, it would be really long. You can slice parts of strings in pandas in an element-wise fashion using stir.slice. So we'll show how to do that. We'll take our comments, then say .stir.slice, and this is going to take a slice from the 0th index up to the 10th index for every single comment. So every single comment in our series of comments here, we're going to get the first 10 characters only. So let's run that and see that we've sliced off the first 10 characters. Alternatively, we could use our normal indexing operations to take slices of the same sort. So we could have just said comments.stir and then used our indexing slice. So use the square brackets to index into the strings and go from 0 to 10, and then do .head, and that would have got us the same thing. Now, if you want to take a slice of a string and replace it with something else, you can do that too with the slice.replace method. So we'll show how to do that. We'll take our comments.stir, and then say .slice replace. And then for the arguments, you just put in the slice as the first two arguments. So we're going to slice from index 5 to 10, and we'll cut that out and replace it with this, wolves rule. So all of these comments now should be having this wolves rule added into them. Now, if you want to replace something within a string, but you don't want it to be based on index positions like this, you want it to be based on the actual content. So like you want to replace a given word with another word, no matter where that word appears in the string. You can do that with the .replace method. So we'll show how to do that here. We're going to do comments.stir and then .replace. The first argument here is what you want to replace. So we're going to replace the term wolves, and then comma, the second argument is what you want to replace it with. So we're going to replace wolves with pups. So when we run that, any instance of wolves has been replaced by pups. You can see in this first comment before, it said the T-wolves, ... Well, now it says the T-pups, ... Now, a common operation when working with strings is to test whether a bit of text contains a certain substring. So you can do that using the .contains function. Here we're going to say comments.stir.lower, so we're making everything lowercase. Then we're going to say .stir.contains, and now we're going to pass in the thing we're trying to detect in all the strings and see if each comment contains this. And we're going to search for wig, and then this bar means or, and then Drew. So basically we're trying to search for comments about Andrew Wiggins, who is a basketball player on the Timberwolves basketball team. So Wig is a part of his last name and Drew is a part of his first name. So any comment that contains either of these constructions will return true for this. So we're going to save this function call as a logical index, where every entry in the index is true when the comment contains one of these and is false when it doesn't. And then after running that, we can use this index to grab the comments where it's true by using it as an index back into the data. So we can take the index we created and then say comments, use the logical index to grab the comments that are about Andrew Wiggins, and then we'll say .head10 just to look at the first 10 of them to confirm that they all do contain some information about Andrew Wiggins, or at least that they contain one of these substrings. I suppose you could have a comment that contains one of these substrings and it's not actually about him, but we'll see what we get here. Now, for interest's sake, we could use this data to calculate something we might be interested in, such as what proportion of all of the comments about this NBA team are about this particular player. We could do that by taking the length of the comments that are about Andrew Wiggins, so the ones that conform to our logical index, divided by the length of all the comments. And we can see that approximately 6.6% of all the comments on this subreddit have something to do with this player. Pandas has a few more useful string functions, but before we go any further learning them, we should touch on regular expressions. A regular expression is a sequence of special characters that lets you define a pattern that can match strings of different lengths that are perhaps made up of different characters. For instance, when we used the stir.contains function above, we supplied it with what is actually a regular expression. When we wrote wig and then bar Drew, that is a regular expression that will match any string that contains either wig or Drew. That bar is a special character in this case that's telling the regular expression to match either of those things. But regular expressions have a lot of other special characters that can allow you to match strings of a lot of different types, so they can be very useful for various string processing tasks. For example, the period character in regular expressions is a meta character that will match anything other than a new line. So we could, for instance, use the period to match any word that ends in ILL. We will show an example of this. We're going to make a Pandas series of some different words, and we can see that all of these words end in ILL except for gull. So if we wanted to write a regular expression that could match all of the words that end in ILL, we could put a period first, so that's saying match any character, and then match exactly ILL. When we run stir.contains here, it should match all of these ones that end in ILL regardless of the starting character, because the period is matching any character that comes before the ILL. but the gull will not be matched because it doesn't have ILL in it, it has ULL. Now, square brackets in Python regular expressions let you specify a set of different characters to match. So, for instance, if we used it here and enclosed capital T and lowercase t, this regular expression will then match a starting capital T or lowercase t followed by ILL. So when we run that, we see we get two trues, one for till because it starts with a T and then ends in ILL, and one for still because it does have a T before the ILL. It isn't capitalized, but because we enclosed these two different forms of T, that was matched as well. There are a lot of special characters in regular expressions that can allow you to match different things. I have written down some of the more common and useful ones here, so I'll just quickly go through and show you what some of these do. So if you include the range A through Z in square brackets, that will match any lowercase letter. A through Z capital will match uppercase letters. 0 through 9 in the brackets will match any digit. This construction here will match lowercase letters, uppercase letters, and numbers. And adding the caret symbol at the beginning within square brackets matches characters that are not in the set. So if we instead start this off with the caret A through Z, well, that's matching any character now that is not a lowercase letter. Outside of square brackets, the caret symbol will search for matches at the beginning of a string. For instance, if we make a series with some new strings in it, where did he go? He went to the mall, and he is good. And we want to match strings only where he occurs at the very beginning of the string. We can do that using the caret. So we'll say stir.contains, and then use the caret to say we want to match it at the beginning. And we'll say we want to match he with an uppercase or he with a lowercase. So when we run that, it should match the second one and the third one because he occurs at the beginning of both of those. But it will not match the first one, even though he does appear within the string, because it's not occurring at the very beginning. So let's just run that and see that we do get false, true, true there. And the opposite of the caret character in this case is the $sign character. That will search for matches at the end of a string. Now, parentheses in regular expressions are used for grouping and enforcement of proper order of operations. An asterisk will match 0 or more copies of a preceding character. A question mark matches 0 or 1 copy of a preceding character. And a plus will match 1 or more copies of a preceding character. So to give an example of how we could use these, let's make some new strings here that contain some A's and B's. And now we can run stir.contains and use a regular expression to capture some of them. So let's walk through what this regular expression is doing. We're saying A star, that means match 0 or more A's. Then it's saying B, match a single B. And then period plus. Well, the period is a special character that matches anything other than new lines. So period plus means match any number of any characters after that other than new lines. So let's walk through and see which of these substrings this should match. Well, here we have 0 or more A's. We have a single B, and then we have 1 or more of something after it. So this string should be matched by this. Here we have a single B. Well, a single B does conform to 0 or more A's, and then a single B, but it doesn't have anything after it. And here we need at least 1 of something after it, so this will not be matched. The AA will also not be matched because our regular expression requires a single B. And both of the two remaining ones will be matched because they contain a single B followed by at least something, and the optional A is there, but it doesn't have to be there. So when we run that, we see that we get true, false, false, true, true. That matches up with what we thought it would be. Now I'll go through a couple more special characters you can use in regular expressions. Curly braces will match a preceding character a specified number of repetitions. So if you use curly braces M, then the preceding element would be matched M times. If you use curly braces M and then a comma, the preceding element is matched M or more times. And if you use curly braces M, comma, N, the preceding element is matched between M and N times. So these curly brace constructions just give you a little bit more control over how many times you're matching a letter, as opposed to just say period plus that's saying match it an unlimited number of times. Now, one final thing we will note about regular expressions is that since it uses a lot of special characters like period to denote things, what happens when we actually want to match a special character itself? For instance, what if we want to match a period? We can't just write period because a period is a special character that matches anything. So if we want to actually match a period, we have to use backslashes to do that. In regular expressions, backslashes are an escape meta character. So if you want to match an actual meta character, you put a backslash before it, and that will escape the normal behavior of that meta character and just turn it back into the normal version of itself where you can actually match it in a string. So we'll give an example of how we might do that here. We're going to provide some new strings that have some periods in them. So if we wanted to match the periods themselves, we'd have to, instead of saying just match period, match backslash period. And the backslash says we actually want to match period, the character, and not use this period as a meta character. So when we run this, we should be matching things that contain a period and then a space after it, which means in this case we're going to be matching Mr. Ed and Dr. Mario because they both have period space. And if you want to use a regular expression to detect backslashes, well, backslash itself is a special character. So to escape a backslash, you need to write a backslash to escape itself, but then you also need an escape to escape that backslash. So it's kind of hard to even think about, but if you want to do that, you need to write 4 backslashes. So if we wanted to match the backslash character here in Miss/Granger, we could do that by writing 4 backslashes here. And when we run that, we see that we do return true because it has detected that backslash. Now, alternative to doing this 4 backslash construction that's a bit confusing, we could use a raw string. It's just a special type of string in Python that simplifies some of these oddities when performing regular expressions. To do a raw string, you just preface a string with a lowercase r like this. And if you do that, you actually only need to use 2 backslashes. One for the character itself, and then the other one to escape it because it is a special character. And this will do the same thing. So if you're getting into some complicated regular expressions, it might be a good idea to use raw strings for that because that can simplify some of the constructions you might have to write. Now, thus far, we've been using regular expressions within the context of Pandas string functions. You can use regular expressions in built-in Python as well, but you have to import the regular expression library. To do that, you just do import RE for regular expressions. And there's a host of functions within that built-in package as well that you can use to run a lot of regular expression functions. Now, the Pandas string functions we've been using so far, a lot of them accept regular expressions to match strings instead of just full substrings. Actually, 2 of the functions we've looked at already accept regular expressions. The stir.contains and stir.replace functions, both of those accept regular expressions, so you don't necessarily need to write out full substrings if you want to do more complicated string matching, and replacement. Now, to close out this section, we'll look at a couple more useful string functions in Pandas and use a simple regular expression with them. The .count method will count the number of occurrences of a given pattern within a string. So if we say comments.stir.count and we use this regular expression, wolves, starting with either a capital or lowercase w and then the rest of the word wolves, we can count how many times the word wolves appears in each comment. So if we run that, we can see that the first comment here, or comment 0, said wolves twice. Some of these other comments don't even contain it at all, but comment 3 does. So it's fairly common for a Timberwolves related text to have that term in it. And we can use the findAll method to get all of the matches and then return them all as a list. So here, if we write comments.stir.findAll and we use the same string as before, when we run that, we see we have been returned lists for each comment and all of the instances of the match strings. So since that 0th comment contained 2 instances of wolves, we see a list with wolves twice. Now that we've learned a bit about different string functions that we can use in Python and some about regular expressions, we're going to close out the lesson by doing a slightly more complicated regular expression that might be a little bit more useful and something you might actually want to do on real text data. So what we're going to try to do here is write a regular expression that will allow us to identify posts that have web links in them. So web links begin with the characters HTTP or HTTPS. So we could start by making a regular expression that matches those specific substrings. To do that, we could say comments.str.contains, and for our regular expression here, we'll just say HTTP and then an optional S. The question mark says the preceding character is optional. And then after that, we'll also include the colon character because that is also in a web link. If we run this, it will create a logical index where it's true when it matches this substring and false when it doesn't match. We could then take that logical index to index back into the comments and filter down to only the comments that contain this construction that matches with web links. So let's run that, and then we will both print the length of that to see how many posts there are that have web links, and we'll also look at the first 5 comments with web links just to see that they do in fact contain what appear to be web links. Now it does appear that the comments we matched all do contain web links of some kind, but this is a pretty simple way of trying to match web links. So if we wanted to be a little bit more specific with what we are doing, we could make a more complicated regular expression. So we'll give an example of trying to find all the different web links in each comment using a new construction. So here we're going to say post with weblinks.str.findAll. So findAll is actually going to find them and return them all in a list. And then we're going to find this regular expression. Now this probably looks a bit confusing, so let's walk through it. The beginning of it is actually the same as what we did before. We're going to match HTTP, an optional S, and then a colon. So that's all the same. After that, we have a bunch of stuff in square brackets, but it starts with the caret character. Well, we learned that the caret character says match things that are not this. So we're matching things that are not a space because spaces tend to break up web links. We want to match things that are not a newline character. /n is newline character. And we also want to match things that are not a closing parentheses. So we have backslash in there to escape the closing parentheses because that is a special character for regular expressions. So we have to escape it to make sure that we're actually matching that character itself. And then after this whole square bracket, we're saying plus. So that's saying we want to match at least one character that conforms to this and any number of characters that conform to that. But then as soon as our string shows any of these, a space, a new line, or closing parentheses, then it will stop and only match up to that point. So let's go ahead and run this and see what the links we get actually look like. And we can see it looks like we did manage to grab what appear to be links. We have some YouTube links here, some things from Instagram. So this is probably doing a bit of a better job matching web links than the previous more simple construction would have done, but it might not be perfect. Anytime you're trying to match something that is quite complicated and is something that lots of other people have probably wanted to match in the past, for instance, web links or email addresses or somewhat common constructions of that sort, you can probably search the internet and find a fairly good regular expression that someone else has written to match it and use that instead of trying to write something yourself, because writing something that does a really good job yourself can be a bit tricky if you're not very good at writing regular expressions, and there's no use reinventing the wheel on trying to match something that everybody else has probably tried to match in the past, and you can just reuse code that they know works well for that. Now, it is also worth noting that these regular expression patterns we've learned about in this lesson are specifically for Python. A lot of them will carry over into other languages and using regular expressions in other languages, but that is not a guarantee. There might be some slight differences depending on what language you're trying to use them with. So these skills will transfer over to other languages to some extent, but just know that some of these constructions could be different if you're using a language other than Python. So now that we know a bit more about how to work with text data in Python, in the next lesson we're going to turn our attention to numeric data and go through various operations and pre-processing steps you might want to run on numeric data to get it ready for analysis. If you found this video useful, drop a like, hit subscribe, and I will see you again next time.